Good morning, everyone. So today I will be presenting the extra credit, which was why didn't we use the A star algorithm in our um, initial submission as our optimized algorithm. So before we start with why didn't we do it, let's start with what A star algorithm is. So initially it was founded by um, three people: Peter Hart, Nils Nilsson, and Bertrand Raphael. And the idea was that they wanted to make a mobile route robot that could plan its own path. Um, so it, this was the machine they made, and to make this machine work, they discovered the A star algorithm. So they initially published it in 1968, and the formula they used was f of n, g of n plus h of n, where h was the heuristic we estimate we take. But in our class, we found a much better or understandable formula, which was minimum min of distance and cost, and we used this formula to find the A star algorithm and use it to find the minimum distance. Now, how does it apply in our case? So initially, this was the problems we are trying to solve in our initial submission. So we have 10 nodes: A, B, C, D, F, G, H, I, J, K, and we have all the miles and the speed that we can go on that node. From A to B, is 5 miles. You can go at a speed of 45 miles per hour and similar. Now, in our optimization, we do mention A star algorithm, but there were two main reasons we didn't choose it. But before we do that, we first need to decide how do we do the A star. So if you have two nodes, for example, well, from let's say you want to go from A to E, what you will do is you will draw a straight line from A to E. Now, you will take an estimate of it. So if you wanted to go from A to E, you will take estimate like, let's say, 4 miles, and the speed you can go with is like, let's say, 30 miles per hour. Now, when you do this, since we are also considering speed and we were also considering the fare, so in our algorithm we take care of that, how the fare, distance, and base, and the demand level, all of them are taken into consideration. But it was very difficult to do it with A star algorithm. And also the time complexity. The time complexity for our customized depth first search is k times n, where k is the number of simple paths and n is the number of nodes per path. But for a A star algorithm, if we want to go search towards the goal, it can be b raised to the power of d, which is very bad. So that's why in our case, we chose our optimized depth first search.